Welcome back, and we're going to continue solving that question I left you all with. And the first, let me write down the elements just so we can capture them. The soil I gave you with beryllium, magnesium, aluminum, astatine, I believe. Yeah, AS or arsenic, sorry, arsenic, tellurium, polonium, and rhodium, right? Okay, good. All right. So these are our elements, okay? So now all I wanted you to do was sort them out like this into the last one, right? Now first what you want to do is understand the rule, okay? Size, okay? Size decreases, okay, from left to right. Again, I am not going to focus on the exceptions, and size increases as you go from top to bottom on the periodic table. This does not mean it has to be in a row. Even if across, the rule obeys the same. So if you look at your periodic table really quick, let me bring the periodic table just on my screen. Okay, so if you look at these elements, okay, first put them in a place and then you can shuffle if you have to get the correct order. Okay, so we got beryllium and magnesium, so look at it that way first. Okay, so we got beryllium and magnesium, so magnesium is definitely bigger than, just don't put any symbols, just put them where you think they go. Okay, so magnesium is definitely bigger than beryllium, right? Because it's below beryllium, right? All right. Now what other elements we got? We got aluminum and arsenic. Where is aluminum? Well, aluminum is in the same row as magnesium, right? All right. So that means that's left to right. That means aluminum must be smaller than magnesium, right? So for now, I'm going to put an arrow and said tentatively that's kind of where aluminum should go, because aluminum and magnesium are in the same row and aluminum must be smaller than magnesium because we have gone from left to right. All right. This is the way I would work it out if you're learning the material. Okay. If you're me, then yeah, you can go straight away with the ordering of it. All right. Now let's go back and find where AS is. AS is arsenic, and arsenic is below both magnesium and aluminum, right? That's what you need to focus on. You don't need to pinpoint where it is, left, right, nothing. AS, which is arsenic, is below both magnesium and aluminum. So it's below these two. So arsenic must be somewhere here. It's bigger in size than both magnesium and aluminum. And let's go find Te. Te is even below arsenic. So that means it's got to be even bigger. All right, now let's go find Po. Where's Po? Po is right below Te, so that's got to be bigger as well. All right, now where's rhenium? RH. Where's RH? Do you see RH? Okay, RH is actually on the same row as Te, okay, but it's above Po. So what does that mean? RH is bigger than Te, but it is smaller than Po. Does that make sense? Because it's in the same row. So RH is bigger than Te, but it is smaller than Po. So RH must be here. That's the order. All right, we got all the elements situated. Now let's go ahead and draw our order. So beryllium is smaller than aluminum, which is smaller than magnesium. Magnesium is smaller than arsenic. Arsenic is smaller than tellurium. Tellurium is smaller than rhenium, and rhenium is smaller than polonium. Here we go. You saw how I approached the whole process. I didn't just make more chaos than it need to be. Okay, just the right amount of chaos. But this is how I do it to start off, and this is foolproof. Most likely you're never ever going to get this wrong. All right. Now this is as far as just elements go in a ground state. Now how about we take it one notch further and maybe include some ions of that same element in there. All right. Okay. Now this is going to get a little tricky. So how about let's do a list of just ions first, and then we start mix and match together. All right. So how about I don't think I even need to look at a periodic table. Let's just throw in some ions. Na plus 1, calcium plus 2, okay, N3 minus, O2 minus, and then aluminum 3 plus. Let's say this is all I have, okay. First, let me give you some, since we're still on the atomic radius / size, the same rules apply, but we have to understand, we have to add an appendix to our understanding before we can go further, proceed with it, okay. The more the positive charge, okay, the smaller the ion, irrespective of where it is in the periodic table. Only when we compare like ionic charges, say +3 and a +3, the smaller the ion, okay. The more the negative charge, okay. How about let me do one more here just to get this going. So maybe I will throw in, say, chromium 3 plus, okay, to just enforce my idea. The more the negative charge, the larger the ion, okay. It's only when you compare two ions that have same number of positive or negative charge, that's when you can really apply the rule that we've learned as far as atomic size goes, okay. So again, ascending order, we're going from the smallest to the largest, okay. This is the smallest, this is the largest, okay. All right. So the smallest would be, well, as I said, the more the positive charge, the smaller the ion, right. Now we have a problem. We have two ions, Al3 plus and chromium 3 plus. They both have plus charge. Now we have to apply our rule and figure out of those two which one would be the smallest. Okay, they're both smallest, but out of those two, one would be definitely smallest. Now you go to the periodic table and look up where aluminum and chromium is. Chromium is clearly below aluminum, so typically it is bigger. So aluminum 3 plus would be the smallest of the two, and then chromium 3 plus would be slightly above it. Okay, now again, more positive charge, smaller the ion. We got one more, calcium 2 plus, which is +2, and then we got sodium. Here we don't need to even bother to look up the rule. Now comes the rest of the guys. So again, if it is more negative, you don't need to even worry about the rule. So O2 minus will be up on the list, and then N3 minus would be the last, because it's the more negative charge, the larger the ion. So here we go. So this is when you have a combination of ions, okay. Now let's go back and do one where let's mix them up. Okay, that's even easier, all right. So let's do, say, sodium, chromium 3 plus, calcium 2 plus, okay, Na plus 1, and aluminum 3 plus, okay, and then O2 minus, F minus, and Cl minus, and N3 minus. Now we have a combination of ground state elements and ions, right? So whenever you have the situation, again, you got to give your importance to the ions first, because that makes your life easy, right? So again, we're going from the smallest to the largest, right? This is where your largest going to be on the list, and this is where your smallest going to be on the list. Okay. All right. So just like that, we got 3 pluses, so they got to be the smallest. But again, earlier we confirmed that chromium is below aluminum on the list, so it's got to be slightly bigger. So aluminum 3 plus is first on the list, and then chromium 3 plus, and then obviously we give preference to our next pluses in line, so it's calcium 2 plus and then Na plus 1. Now Na plus 1 is definitely going to be smaller than Na because one is with the charge, one without the charge. All right, we got all our positives and ground state done. Now comes all the negatives. All right, now if you look at it, the F minus and Cl minus have both 1 minus. So now we have to apply the rule, and if you go to our periodic table, chlorine is below fluorine, so chlorine's got to be bigger. So F minus and Cl minus. Now the rest is history. O2 minus is probably smaller than N3 minus because here we don't need to even apply the rule, and there we go. That's our finished order. Okay, so the radius, you cannot simply translate the idea of radius from math into chemistry, even though how you measure radius is the same. How it's applied, you got to understand the rule a little bit more. Again, we didn't look at the exceptions because I don't want to confuse you any more than you already may have with introducing the exceptions. But if any of you are interested, hey, I do want to know those exceptions, please shoot me an email and I'll be able to explain to you. Or maybe if I have time, I will make a video for the exceptions separately. But again, if you can comprehend that and incorporate it into your existing knowledge, you're just going to force yourself to have issues. So I think this is where I'm going to stop my discussion on atomic radius, and then we're going to go to the next likely topic, which is ionization energy, because it ties into the word ion, so it only makes sense that ionization energy is likely the next candidate. So I'm going to stop here, and then when I come back with my new video, I will start talking about ionization energy. Now, if you have any questions, please feel free to create your own list like the ones I created and play around with it. And if you have questions, you can email me and say, hey, this is the list I created. How am I got this? Is this right? Okay. I can tell you if you're right or wrong. And if I tell you it's wrong, why don't you go figure out why you did wrong and then come back and ask me. I think that's the better way to do it than me giving you the correct answer on the list of things you created. All right. I'll see you back with ionization energy. All right. Bye-bye.